students, welcome to the next video of derivative. In today's video we are going to see the derivative of composite function. As we had discussed about the composite function in function chapter, right? Composite function are merged function, right? When two or more functions are merged, then that combination function, combined function is known as a composite function. Now in derivative we are going to see how to find the derivative of such type of function. Now this derivative is known as a chain rule. Why chain rule? Because if there are two merged function, okay, suppose there is a function f g of x, okay, where f of x is root x and g of x is x square plus 1, then first we have to find the derivative of first function. Okay, see here, f of x is under root of x square plus 1. Okay, so first function is in the form of root x, and we know that derivative of this root x, derivative of root x, that is equal to 1 upon 2 root x. Okay, hence derivative of this function root of x square plus 1, that will be 1 upon 2 root of x square plus 1. Okay, now this is not a complete derivative. Why? Because this is in the form of root x but not exactly root x. Now the second function is x square plus 1, and we have to find the derivative for x square plus 1 also, and hence we are going to do the multiplication, means into derivative of second function. So derivative of x square plus 1. Okay, so this will complete the whole derivative procedure. So first we have to find derivative for root x, we have to apply the formula of root x, and then we have to find the derivative for x square plus 1. Okay, so composite function, suppose if the function is in the form of f of x raised to n, then first we have to apply the x raised to n formula. Derivative of x raised to n is n into x raised to n minus 1 into derivative of f of x. Okay, so that is the concept of chain rule. Clear? Suppose function is sine of e raised to x. Okay, sine e raised to x is given. Now sine e raised to x is not a single function. Sine e raised to x is a combined function. Here two functions are combined. Functions are sine x and e raised to x. Okay, now first function is sine x. In sine x, in place of x we have substituted e raised to x. Okay, so first we have to find the derivative for sine x. Now derivative for sine x is cos x, so here it will be cos e raised to x. Derivative of sine e raised to x is cos e raised to x into, now we have to find the derivative for e raised to x for second function. So that will be cos e raised to x into, now derivative of e raised to x is e raised to x. Okay, so basically chain rule is, first step is to identify how many functions are there, and then you have to find the derivative of all the functions one by one. Okay, now let us see some examples. So example 1 is differentiate with respect to x. What is given? X raised to 2a minus 2a raised to 2a plus a raised to 2x plus 2x raised to 2a. Okay, now let us start. So derivative dy upon dx, that is equal to first x raised to 2a. Now since derivative of x raised to n is n x raised to n minus 1, so same formula we are going to apply in x raised to 2a. So x raised to 2a will be 2a x raised to 2a minus 1. Okay, this step. Then 2a raised to 2a. This is nothing but a constant term. Why constant term? Because there is no variable. So 2a raised to 2a is constant and derivative of constant is 0. Okay. Then next is a raised to 2x. Okay. Now a raised to 2x, that is equal to a raised to 2x. Let me rub this side so I can write the next part. So wait a moment. Yes. Now a raised to 2x. So we are going to use the formula of a raised to x, that is equal to a raised to x into log a, right? So a raised to 2x will be a raised to 2x into log a, right? But a raised to x, in place of x, what is there? There is a 2x. So we have to find the derivative of this 2x also, because it is a combined function. A raised to 2x is a combined function. A raised to 2x, this is a combined function. Here we combine a raised to x and 2x. In place of x, I am writing 2x. So next is derivative of 2x. So finally what I am getting? I am getting a raised to 2x. This is not a, this is 2x. Okay. So a raised to 2x into log a into derivative of 2x, and derivative of 2x is 2. Okay. Then next is derivative of 2x raised to 2a. Okay. Now 2 raised to 2a is constant. So 2 raised to 2a will be out from the derivative. So derivative of this part 2x raised to whole raised to 2a. That means it is a derivative of 2 raised to 2a into x raised to 2a, right? Now 2 raised to 2a is constant, so it will come outside the derivative, and we have to find derivative for x raised to 2a. Okay, so that is equal to 2 raised to 2a or 4 raised to a, right? Then this will be x raised to 2a. X raised to 2a means again we have to apply x raised to n formula, that is equal to n x raised to n minus 1. So x raised to 2a, that will be 2a into x raised to 2a minus 1. So 2a into x raised to 2a minus 1. Or second thing is derivative of this x raised to 2a. First, this is given as x raised to n form, so we have to apply x raised to n formula. So that is equal to 2a, okay, into 2x raised to 2a minus 1. This whole term, consider this whole term as x. So n into x raised to n minus 1 into derivative of 2x, this part. Why? Because 2x is a composite function. It is not a single function. It is a combined function. In 2x we have combined x and 2, right? So derivative of 2x, second function. So derivative of 2x is 2. So this is the final answer. Let's see some more example. Here f of x is given as x square and g of x is given as 3x plus 5. Question is find the derivative of f dot gx. Okay. Now y is what? Y is f dot gx, right? F dot gx is composite function. This means f g of x, right? Now f g of x means g of x whole square, because f of x is x square, right? So f of gx will be g of x whole square. Now g of x is 3x plus 5. So finally y will be 3x plus 5 whole square. Okay. Now we have to solve this. Now y is equal to 3x plus 5 whole square. So derivative dy upon dx will be, first we have to apply x raised to n formula. So x raised to n is n x raised to n minus 1. So this will be 2 into 3x plus 5 raised to 2 minus 1 into derivative of 3x plus 5. So 2 into 3x plus 5 into derivative of 3x is 3. Derivative of 5 is 0. So finally what I am getting? 6 into 3x plus 5. Okay. See one more example. Again question is find dy upon dx, but y is given as cos square x. Okay. So differentiating with respect to x, derivative of y will be dy upon dx. Okay. Then here cos square x, this cos square x is nothing but cos x whole square, and derivative of cos x whole square means I have to apply x raised to n formula. So that will be x in n into x raised to n minus 1. So cos square x will be 2 cos x raised to 2 minus 1 into derivative of cos x. So that is equal to 2 cos x into derivative of cos x is minus sin x. So minus 2 sin x into cos x. Okay. Then that is equal to minus sin 2x. Okay. Multiple angle formula. Since sin 2 theta is 2 sin theta into cos theta. Okay. So by using this formula we get 2 sin x into cos x as sin 2x. Okay. Then next is find dy upon dx if y is equal to e raised to 3x into sin 2x. Now here as you can see these are two different functions, right? There are two functions, u is e raised to 3x and v is sin 2x. Okay, and we have to find dy upon dx for this function, means u into v form. So first we have to apply u into v rule. So e raised to 3x into derivative of sin 2x plus sin 2x into derivative of e raised to 3x. So e raised to 3x into derivative of sin 2x is cos 2x into derivative of 2x. Okay. We also have to find derivative of 2x because this cos 2x is a composite function. Cos 2x is a combination of cos x and 2x. Okay. So derivative of 2x, then plus sin 2x into e raised to 3x, right? Derivative of e raised to 3x is e raised to 3x into derivative of 3x, because e raised to 3x is also a composite function. Here e raised to x and 3x, these two functions are combined, right? So finally what we are getting? We are getting e raised to 3x into cos 2x, then derivative of 2x is 2, then plus sin 2x into e raised to 3x, then derivative of 3x is 3. Now take e raised to 3x common, then what I am getting? I am getting 2 cos 2x plus 3 sin 2x. This is the final answer. Okay. See one more example. Here y is given as root of sin 2x and we have to find dy upon dx. Now this root of sin 2x, here how many functions are combined? Here 3 functions are combined. First is root x, then second is sin x, and third function is 2x. right? There are three functions, root x, sin x and 2x. So first derivative of root x is 1 upon 2 root x. So derivative of root sin 2x will be 1 upon 2 root sin 2x into derivative of sin 2x. Now derivative of sin x is cos x. So derivative of sin 2x will be cos 2x into derivative of 2x. Now derivative of kx is k. So derivative of 2x will be 2. Okay. So derivative of 2x is 2. So finally what I am getting? I am getting 2 cancel, cos 2x upon root sin 2x. Okay. See some more example. Y is given as e raised to x raised to 3. Okay. X raised to 3 plus 2x. Here y is e raised to x raised to 3 plus 2x. Now differentiating with respect to x. So here e x raised to 3 plus 2x. Again this is a composite function. First function is e raised to x. Second function is x raised to 3 plus 2x. Then derivative of e raised to x is e raised to x. Here we have to use u plus v rule. Right? There are two different functions with plus sign. So u plus v rule. So first derivative of e raised to x cube plus 2x will be e raised to x cube plus 2x into derivative of x cube plus 2x. Then derivative of x cube is 3x square plus derivative of 2x is 2. Okay. So that is the answer for this. Now see the next one. Y is equal to 5 raised to root x. Now 5 raised to root x. How many functions are there? First a raised to x, then root x. Okay. So derivative for a raised to x is a raised to x into log a. Derivative for root x is 1 upon 2 root x. So differentiating with respect to x, dy upon dx will be derivative of 5 root x will be 5 root x into log 5 into derivative of root x. Okay. Now derivative of root x is 1 upon 2 root x. Okay. So finally we will get 5 root x into log 5 into 1 upon 2 root x. Okay. Then next is, if y is equal to log e raised to x into x square, then find dy upon dx. Now differentiating with respect to x. So dy upon dx will be this log e raised to x into x square is a composite function. First function is log x. Second function is e raised to x into x square. Okay. Derivative of log x is 1 upon x. Here you have to use u into v rule. Okay. So derivative of log e raised to x into x square is 1 upon e raised to x into x square into derivative of e raised to x into x square. So e raised to x into derivative of x square. Derivative of x square is 2x plus x square into derivative of e raised to x. Derivative of e raised to x is e raised to x. Now take e raised to x common. So e raised to x, I am taking e raised to x common. So e raised to x into, here it is 2x, here it is x square. So 2x plus x square upon e raised to x into x square. Now e raised to x cancel. So what I am getting? I am getting 2x plus x square upon x square. Now again take x common from numerator. So what I will get? I will get 2 plus x upon x square. So again 1x cancel. So finally what I am getting? I am getting 2 plus x upon x. That means this is equal to 2 upon x plus x upon x. X cancel. So 2 upon x plus 1. Okay. So final answer is 2x, 2 upon x plus 1. Then next question is find dy upon dx if y is equal to log x square plus 2x plus 5. Okay. Now class, again see this log x square plus 2x plus 5 is a composite function. First function is log x. Second function is in the form of x square plus 2x plus 5. Derivative of log x is 1 upon x. And here we have to use u plus v rule, right? So let's start differentiating with respect to x. So derivative of y will be dy upon dx. Derivative of log x square plus 2x plus 5 is 1 upon x square plus 2x plus 5 into derivative of x square plus 2x plus 5. Now derivative of x square is 2x. Derivative of 2x is simply 2 and derivative of 5 is 0, constant, right? So derivative of constant is 0. So what I am getting? I am getting derivative as 2x plus 2. Now take 2 common. So final answer is 2 into x plus 1 upon x square plus 2x plus 5. Okay. See one more example. Find dy upon dx if y is equal to e raised to log x to the base e. But we know that a raised to log x to the base a is equal to x. Okay. If this base and base of log both are same, then value is simply x. Okay. This is the law of logarithm. So by using this law, we get e raised to log x to the base e as simply x, right? Now y is equal to e raised to log x to the base e, and this is equal to only x. So finally what I am getting? I am getting y as x. Now I am differentiating with respect to x. So dy upon dx, that is equal to derivative of x, and derivative of x is 1. Okay. So with this I am concluding my today's video. In today's video we had seen about the composite function, means how to find the derivative of composite function. That means we have discussed about the chain rule. Okay, and we saw some example based on this chain rule. So thank you students.